Okay? So, here's what I will tell you concerning redox. It will take a while to do a redox problem, especially at first until you're used to everything. It will take a level of attention to detail that you are not used to in honors. Because you drop one hydrogen somewhere along the way here and your whole result is just screwy. So it's going to take time, it's going to take patience, it's going to take attention to detail. But if you follow these steps and pay close attention, you're guaranteed to get the right answer when you're done. And the key to making sure you get the right answer is getting the correct number of electrons on both sides. Once you've got the number of electrons correct, if you've done the math right with everything else, it'll all just fall into place. Okay? So it looks hard, and it is a little, but it's really more time-consuming and, I don't know, meticulous than it is difficult. The basic ideas behind redox are things that you've known as long as you've been in my classes. Conservation of mass, conservation of charge, etc.
So
Okay?
what makes it so good as to make it worthy to be on the t-shirt?
What's that?
What makes it so good as to make it worthy to be on the t-shirt?
Because there are, let's say right now, probably 19 people in this building who could do a problem like this. Maybe as many as 24. Certainly no more than that.
Is that including this class?
Yes. You are among the elite.
Sweet.
How's it feel?
Put that on college
A little
There you
nerdy.
go. A little nerdy. Well, what can I say?
I don't think when you're operating on someone's brain, you'll stop and think, I feel like a nerd for being one of the few who can do this. But you might.
But you might.
No, they might have that thought, like, pass through your head.
The nurse might say to you, you are
And while you're
a
thinking
nerd,
about that,
doctor.
you're distracted and you have a brain.
And you'll say, thank you, my chemistry teacher would be so proud. Moving on, scalpel.
Or thank you, I enjoy my paycheck.
Yeah. Yeah,
So
that's
distracted by
true.
thinking about all this, you kill the guy you're operating.
That happened in
Oh.
this TV
Case, you
show
better have
that I was
insurance.
watching, and like the son, like the
Ooh.
doctor was operating on the mother, and then he accidentally killed her, and so then the son got all mad and like took revenge on the doctor's daughter.
Hey, I got a question for you.
Crazy.
What do you call the ratio of sine over cosine?
Tangent.
There we go. Okay. Back on task. We were going off on a tangent.
I did it. Oh. It's not
There we go. All right. Not that that doesn't happen here from time to time, but see, you would get that joke too. Not many people in the school would. All right. Here's the next one. You'll get a charge out of this reaction because this is what happens in your car battery. This is
that's written on the side of the car battery.
First, he died the other day. His wife. His station died.
so. Our first step is to identify what's being oxidized, what's being reduced. Okay? So help me out here. Let's start with the oxidation states.
Okay.
Okay? What is the oxidation state of lead? Yes?
0.
Why?
Because it's in its pure form.
This is an element. Oxidation state is 0 by definition. What about the oxidation state of lead here? Well, let's look at this first. Oxygen is -2, right?
Yeah.
And there's 2 of them, so what does this have to be?
+4.
Has to be +4. Okay? And what about the hydrogen there? +1. Oxygen is
Yeah, -2.
still -2. That means sulfur has to be,
Neutral.
nope.
Yeah, what? Because if there's 2, there's 4.
Remember, there are 4 of these.
+2.
So this is a total charge of -8,
Oh, plus
and this is
6.
+2, so sulfur has to be +6. Okay? Now, what about over here? What is the oxygen?
-2.
What about the sulfur? Now, it might be tricky because we have lead over here, sulfur over here. We kind of have both in question, right? But we don't. Because what form does the sulfur appear in? It's part of the sulfate ion. Guess what? It's still part of the sulfate ion here. You know what that means? The oxidation state remains the same.
Wait, can you repeat that?
Okay. Okay. You got sulfate here, you have sulfate here. The charge of the oxygen doesn't change, and the number of oxygen doesn't change. So the charge of the sulfate has to remain the same. We don't have a law of conservation of sulfur, but anyway. So, if this is +6 and this is -2 and there are 4 of these,
+2.
what's the charge of lead? +2. All right. Those are the oxidation states. Yeah, it is.
Sorry.
You're fine, you're fine. As an approved tangent here, those of you who have iThings, like an iPad or an iPhone, there's an app called Chem Mahjong. One of the things that you can do there is match an element or ion with its oxidation state.
I've seen that. That's not nerdy at all.
That's not nerdy at all. Okay, so what is our oxidation reaction? What is our oxidation half reaction? What is being oxidized? Lead. Okay? So our oxidation half reaction is Pb going to PbSO4. Okay? We're not worrying about balancing by mass or anything yet. We're just, lead is being oxidized from 0 to +2. What about our reduction reaction? What's being reduced here? Yeah.
I have a question about the lead. Why isn't it from the PbO2? Why isn't it being reduced? Like, how do you know that it's being like oxidized instead of reduced?
Well, this is going from 0 to +2. That's an increase in charge.
Right. So
That's
how
oxidation.
But how do you?
This lead is going from +4 to +2,
Which is a reduction.
which is being reduced. Okay? So a reduction reaction is PbO2 going to PbSO4.
So what about the sulfur? The S.
Well, if you look at the oxidation states, does the oxidation state of sulfur or oxygen change? No. It just is there to balance things out. Okay? So, what's our next step? Let's balance each half reaction.